realise. So you might be interested in that object. Do you want to identify this? No? Rho-Ophiuchi, so there's Rho-Ophiuchi, that's Antares, that's Jupiter. And the really interesting thing is, can you find Scorpius against this background? Because the longer you expose for all these stars, they get lost in the background. So if that's Antares, the front of the Scorpion's around here somewhere, down here, and the tail curls up around here. And I think that's Shala and the Sun. And then you've got the butterfly M6 and M7 down there, sorry, the two clusters. You know, the butterfly cluster and Ptolemy's cluster. But it's very hard, isn't it, when you look against these things just disappear. All these constellations disappear. So when we go out at night, our eyes just pick up, you know, you'd be lucky to pick up a few thousand stars on a crystal clear night. But you can at least see patterns of things. Whereas once you start exposing an image for a long period of time, everything disappears and you become much more light, and of course, that's what happens. Anyway. Yeah. Yes. Oh, and of course, everyone recognises the dark horse? No? Yeah, you can see the shape of the horse, the nose there, foreleg, other leg, back leg, other back leg, bit of a tail. Yeah. Some people say, what horse? But I've heard people say that in relation to the Horsehead Nebula. And they really must have been smoking something. Yeah, right. Anyway, so let's get on with the main thing. If I can just get it going here. So going to talk to you tonight about the two Magellanic clouds, which you can see here. So the large and small Magellanic clouds. This is a beautiful 360-degree panorama of the Milky Way. But it's, everyone says 360, but in a way it isn't. It is and it isn't. I mean, it's a sphere flattened out, and what you see in every direction projected into a flat area. So it has an artificial look about it. But you can see, if you look closely, you can just make out the coal sack. Here's the E here, of course, the Aboriginal astronomy. You can see the Southern Cross and the coal sack here, and down here you've got the two Magellanic clouds, and I don't know what that is. Somewhere around here would be Andromeda, but I can't really make out because they're smeared, they're elongated because of the panorama, I suppose. But it's interesting thing, because over here you can see Orion, the Orion constellation just over there. Anyway, I thought I'd include that to get some perspective on where the Magellanic clouds are. Okay. Now, so please ignore the choral accompaniment. I'm
sure you never sing Twinkle Twinkle.
Sorry?
I said I can sing Twinkle Twinkle.
Twinkle Twinkle, yeah. Twinkle Twinkle Little Star would be very good, yes. So anyway, so here are the two Magellanic clouds. Now you do realise they're circumpolar at our latitude, so they're always up in the sky somewhere. And tonight, in fact, these are the other way around at about 11:30. They're swapped around. This one's over this side, that's over that side. And down the middle of that, roughly where I think that might be Gamma Hydra, that star, because it's very red, very orange. So somewhere around there, about there actually, is the meridian, south-north line. So, and there, of course, everyone recognises the small Magellanic cloud and favourite object? We always look at it, 47 Tucano. And the thing that amazes me is when we look at the night sky, the things we look at are things like 47 Tucano. But we ignore the lovely galaxy right next to it, dwarf galaxy. And this galaxy, in fact, I've been known to photograph 30 Doradas up here, that little spot there, which is that beautiful big gas cloud, 1,000 light years ago, which we can in a minute. And that object up there, one know what that is? That's the... No... Canopus? Yeah, Canopus. Yes, Canopus. Anyway, the interesting... I'll move on. So I just thought I'd put in a few dreamy, romantic, just to get you in the mood, and looking at these two beautiful objects, because we ignore them. Every time we do it, well, at least I do, every time we go to Mount Pleasant, it's the last thing I think about is the Magellanic clouds, other than picking a specific item. So you don't really, to look at, you don't actually sort of think about it, but they are wonderful things. to look at and quite bright. I'll just thought I'd show you some of these interesting images. I think that's the, what is it, the ALMA, the Large Millimeter Array, the Atacama, in the Atacama Desert in Chile. Easter Island, Moai statues looking longing up the heavens. And this is the European Southern Observatory VLT, the Very Large Telescope Array, which is incredible. I forget what the Dunwich mirror is. Martin, would you know that?
8.6.
Is it 8.6? There you go. So, and they have this incredible resolution, so fine, that I was reading about this. The headlights, they can resolve the headlights of a car from Earth to the Moon. That's the resolution on those telescopes. So you can imagine the interferometry required to get that resolution from, I think it's 4, is it?
Yes.
3 or 4 of those massive.
Small ones.
Yeah, unbelievable. What an achievement. Oh, and that, by the way, is Gunung Bromo, Mount Bromo. I think that's Bromo in the foreground in Java, East Java. So, and that's just a tree in Africa. Okay. Sorry? The tree? Yeah, I think that was a Madagascar one. Yeah. They seem to be taller. Oh, let's do.
Yeah, you're in the way.
Oh, well, stop complaining. Anyway, let's move on. So here's just a quick, I'll move as quickly as I can. So you can see that the Magellanic clouds are either side of there's the meridian goes up there. Tonight at 11:35, that's exactly the large Magellanic cloud, the small Magellanic cloud over here. We've got their bearings. Yes. An interesting thing is, I'll show you the next slide. Some people hate having meridians going through the middle of their maps, but here's the South Celestial Pole. So if you look up here, these are about 20-21 degrees apart. And down this is about 20 degrees, the large Magellanic cloud from the South Celestial Pole. And up here, the distance is about 17 degrees. They're almost an equilateral triangle. There's no way of finding the South Celestial Pole if you go to too high. Yeah, almost an equilateral triangle. Anyway, I thought I'd show you that one as out of interest. So, some basic facts. Nubecula major and Nubecula minor are the Latin names for the two clouds. Nubecula is actually a diminutive, so it's Latin for small cloud. So the bigger small cloud and the smaller small cloud. That's where it comes from, a bit of Latin. They're irregular dwarf galaxies, part of what is known as the local group. Now, I think, Martin, correct me if I'm wrong, there are about 54 galaxies in the local group.
Something around that number.
Somewhere around that number. So, we've got Canis Major, these two guys, and a whole lot of others that are in this map down below. I can show you a big version of that. It's quite interesting. And that's the local group in there. And that's the Milky Way just beneath it. You can't see it because it's too small. These two Magellanic clouds. The LMC, the Large Magellanic Cloud, 167,000 light years away, the smaller one 200,000 light years away. What does this mean for us? It means that you can't really resolve individual stars in them unless there's supernovas that are taking place, because they're so far away. You need huge aperture telescopes to do that. And of course we've got Hubble. Thankfully we've got Hubble, among other telescopes, to resolve all this magnificent detail inside of them. But they're mainly gas, small gas and stars, as you'll see. They're roughly 20 degrees apart, which is equivalent to 75,000 light years, and a circumpolar, meaning they don't set, at least not at our latitude. And they form that equilateral triangle that I mentioned. It seems to work out quite well. There is some suggestion that the Magellanic clouds have been greatly distorted by tidal interaction. Now, there's two kinds of interaction here. There's a thing called, I'm going to mention it later on, there's a Magellanic stream, which is a tide of gas between the two clouds because they're interacting. And then there's a Magellanic bridge, which is a massive stream of neutral hydrogen that stretches halfway across all the way across the galaxy, but beneath it, beneath the South Galactic Pole. So we might have a look at that later, but I wasn't aware of that. Two completely different scenarios there. So streams of neutral hydrogen connect into the Milky Way into each other, and they both resemble disrupted barred spiral galaxies because they've been interacting. And in fact, I'll show you a picture of that interaction in a moment. Measurements with the Hubble telescope suggest the Magellanic Clouds may be moving too fast to be sort of captive of the gravity of the Milky Way. And in fact, but there are also suggestions that if they orbit, they orbit might take 4 billion years if they orbit each other. If they orbit the Milky Way. Though according to Swinburne, they orbit the Milky Way once every 1.5 billion years. So when you start doing all this reading, you find that there are so many conflicts, factual conflicts or claims that are very, very different. And you wonder who's more accurate. Anyway, and they orbit each other every 900 million years. That's according to the Swinburne Institute of Technology or University of Technology. They are possibly on a first approach. And we are witnessing the start of a galactic merger that may overlap the Milky Way's expected merger with Andromeda, which is supposed to take place in about 4 billion years or something. Andromeda's heading towards us pretty fast. So, all these interesting collisions to take place. The Magellanic Clouds have been known since ancient times. People from South America, there are petroglyphs in Chile, for example, illustrations of them, and from the first millennium in Western Asia. And there was an Arab chap, a polymath. Everyone know what a polymath is? Someone who's good at everything. Basically, called Ibn Qutayba, my pronunciation, Qutayba. His real name is that thing in green. I put it there because I laughed. I mean, I've seen some long names, but that guy takes the cake. Abu Muhammad Abdallah ibn Muslim ibn Qutayba al-Dinawari al-Marwazi. Wow! And the entry in, I think it was Wikipedia, said, we'll just call him this for short. Anyway, that's a very long name. Anyway, he was apparently knew of it, and that was 9th century AD. And then there was a Persian chap after him, whose name eludes me, who also, probably got it here somewhere, wrote about it. And then in Europe, the clouds first were reported in the 16th century by Italian authors Peter I forget his name, Marta, Dangiera and Andrea Corsali, both based on Portuguese voyages. Subsequently, they were reported by Antonio Pigafetta, who accompanied Magellan on his trip around the world. And after that, of course, they became Magellan's Clouds. Someone cooked up the name because they saw them, so they became the Clouds of Magellan. After 1519, 1520, sometime after. In Bayes Uranometria, the LMC and the SMC are officially called by their Latin names, Nubecular, Major and Minor.
Rich,
Yes.
how could the Arab chap see them from?
I would say a couple of things would argue that. Precession. I would say precession would be certainly because, even the Southern Cross was visible, I think, in ancient times. Because of precession, the sky was completely different. So some of these things were visible there, but disappeared again, of course, over the millennia. In fact, aren't our star maps out of date every 50 years or so anyway, because of precession? We have to keep updating them every 50 years or so. Remember Neutron Star Atlas, Epoch 2000, Epoch 1950, Epoch 2000? They used to update every 50 years because, there's quite a significant change over 50 years. Anyway, the small Magellanic Clouds, 7,000 light years across, also known as NGC 292. We're all calling out to each other in the dark. What's the NGC number? There's one to remember. A mass of 6.5 to 7 billion suns. Visible to the naked eye, of course, to us, and from latitude south about 15 degrees north. I always think if you subtract 90, the latitude from 90, you get an idea of how high up in the sky the object is. So it's 60, 70 degrees roughly. Located across the constellations of Tucana and Hydrus. The SMC has a diameter of 4.2 degrees, which is the equivalent of 8 moon diameters in the night sky. That's quite substantial. It contains a large and active population, which I didn't know, of X-ray binary stars, and some of them are high-mass X-ray binaries. It has been proposed by several physicists that the SMC may be in, the small Magellanic Cloud may be in 2 bits, one bit behind the other. It's split in two with a smaller section of the galaxy behind the main part from Earth's perspective and separated by some 30,000 light years. They suggest the reason for this is due to a past interaction between the two. the Small Magellanic Cloud and the Large Magellanic Cloud, and that the two sections are still moving apart, and they've been dubbed the small one the Mini Magellanic Cloud. Now, I don't know whether that's being confirmed. Now, this is an interesting one with the Anglo-Australian telescope, and they've made an interesting, remember I told you about this Magellanic bridge across here between the two Magellanic Clouds? Well, the Large Magellanic Cloud has been drawing material off the Small Magellanic Cloud, and these missing, they're called missing stars, have actually been gravitationally drawn from one to the other. And the research seems to have proven that this is in fact the case. These lost stars were stripped from the small cloud by the gravitational pull of the large cloud in a recent nearby encounter. So I came across that interesting graphic. Here's the other thing, the Magellanic Stream, not to be confused with the Magellanic Bridge, is that as imaged by the Hubble Space Telescope and other, I forget what the lab survey is, I did know that, I've forgotten now. The Magellanic Stream contains a gaseous feature dubbed the leading arm, a stream of high velocity, oops, sorry, my humble apologies, back we go. What happened there? Yeah, a stream of high velocity gas extending from the large and small clouds over 100 degrees. So I've never been aware of such a thing. And here's a sort of map of it, graphic. 100 degrees to the galactic south pole of the Milky Way. So this corresponds to, the actual distance is 180 kiloparsecs, at a distance also south of 55 kiloparsecs. So it's a massive, huge thing. Now, neutral hydrogen, I gather, must be hydrogen that hasn't got any charge. So it's not like ionised hydrogen, which we see in emission nebula.
So Milky Way is robbing material.
Yes, well, there's the tidal interaction. And part of the Milky Way is being drawn off by the Magellanic Clouds as well. There's this interaction. But I think the stream is, the velocity range is huge, up to 400 kilometres a second, which is quite extraordinary.
And you're saying, Richard, it's not visible because it's neutral?
I would reckon you would have to use, I don't know what kind of narrow band you would have to use to image that, or see it, or if they need special instruments, goodness knows. Yeah. Anyway, here we go. So here we've got the, let's look at the Small Magellanic Cloud for a moment. This is from Stellarium, so it's blurry because, when you're on Stellarium. Brilliant in its own right is 47 Tucana. That's my MG47 Tucana. Blown up a bit, enlarged substantially from the original. But there are some beautiful objects in this. For example, NGC 265, a brilliant, quite dense open cluster, 65 light years in diameter, magnitude 12. Which brings me to the whole point, when you look at these things, a telescope of 10-inch aperture might have a limiting magnitude of 15, but to get any real appreciation of these things, you really do need big telescopes, because you're just not going to see in real time, you're not going to see a wonderfully bright image at all, unless you have a 20 or 30-inch telescope or something, where you probably would get a decent image of something like this. But even they are, probably 17th magnitude or something, limited to about 17th magnitude. So, but
Richard, photographically,
different ballgame, of course.
Channel.
Yeah. So when you take pictures, I'm not talking about pictures though. So once you start imaging, it's a very different thing. You can collect light even with a small telescope and get these wonderful, wonderful pictures. So, but isn't that a beautiful cluster? Very tight cluster. And some of the clusters I'm going to show you are actually semi-globular, and they may even compact and become globulars. Some of the scientists think anyway. And there's a Hubble telescope of 47 Tucana, a Hubble image of 47 Tucana. Wow, I'm so jealous. A few other interesting deep sky objects. NGC 290 up here, an open cluster, again 65 light years across. A lot of these clusters are between 60 to 100, 120. Globular clusters are about the same size, up to 150 light years across. The stars here are magnitude 11.7. All the things that you see in both these clouds are at least 10.5 in magnitude. Rarely do you see something brighter than that. So they're faint objects, to say the least. But down here, this beautiful thing here, has anyone ever, I wish Steve's not here tonight. NGC 346 is the brightest, this is the thing, this one here is the energy source, major energy source in the Small Magellanic Cloud. 210,000 light years away. The light, wind and heat given off by those massive stars have dispersed. There are three groups of them, and they've dispersed the gas around the star clusters, forming a surrounding wispy nebula structure. There are some 70,000 stars, and their population, the oldest, they're in three groups. 4.5 billion years is the oldest of the group, of the three groups. And then the younger population are only about 5 million years old. And it came into existence when humans began to walk, or human-like creatures. Lower mass stars take longer to ignite and become full-fledged stars, so the protostellar population is only 5 million years old. So you've got really old stars, not really old, but the age of the sun, and then you've got these very young ones in three groups. So that's an interesting object in itself. I love this. Does this remind you of anything? A familiar Hubble image of, and people image to here. If you look at this pointy
lobster.
No, look at that like a wing and
Oh, the
Eagles, Eagle Nebula M16. Yeah? No? Oh, okay. Anyway, well, it was worth a try. Yes, we've been smoking again. This is the NGC 602. Isn't it beautiful? And its magnitude 15.4, when you know it. So too far away for us to see anything really exciting through anything but a very large telescope. But surrounded by natal gas, natal is in birth, young stars. NG602 is featured, NGC602 is featured in the stunning Hubble image of the region. It's a combination of the X-ray images by the Chandra telescope, Spitzer telescope for infrared, and colour, I guess, or the full range, full spectrum colour. Fantastic ridges and swept-back shapes strongly suggest that this energetic radiation, this has been plagiarised, I'm sorry, and shockwaves from 602's massive young stars that eroded the dusty material and triggered a progression of star formation, moving away from the cluster centre. The image spans 200 light years and has a magnitude of 15.4. Isn't it spectacular? If you look closely, what do you see? Galaxies in the background. But those galaxies are hundreds of millions of light years away. And well and truly in the background. So nothing to do with this particular, which is only about 160,000 light years away. So 200. Okay. Oh, sorry, I meant to say, if you ever go looking for that, it's that's where it is in relation to the Magellanic Cloud, nearby. Still part of it, considered part of it, but on the edges, on the fringes. So the Large Magellanic Cloud, turn to that one quickly. The Large Magellanic Cloud has 700 open clusters. Look at this, 400 planetary nebula and 60 globular star clusters. I was just pleased to see one planetary nebula when I was looking at the map, and you can see this beautiful big ring, like an explosion. It was just spectacular. Down the, I'll show you later. But there are hundreds of them. That's extraordinary. And 60 globular clusters, which is quite substantial. 14,000 light years across, 167,000 light years away, magnitude 0.9. I should say the other one's magnitude 2.7. So the Small Magellanic Cloud, the larger one's brighter, integrated magnitude is brighter. Mass 10 billion times the Sun. And it's part of the local group, and it's the fourth largest galaxy, this one, in the local group, after Andromeda, the Milky Way, and M33, the Triangle. The LMC is also home to the Tarantula Nebula, which we're going to look at in a moment. It's spectacular. It is a Magellanic spiral. The LMC is classified as a Magellanic spiral. It contains a bar, as you can see, a bar structure, but it's distorted and off-centre because of tidal interactions. It straddles the border between the constellations of Dorado and Mensa. And it is a staggering 10 degrees across, so that's 20 moon diameters in width. The Milky Way and the LMC are expected to collide in about 2.5 billion years before the Andromeda collision, which is about 4. So we're going to have a look at a few interesting objects. Probably the most interesting object is down here. This is the Tarantula Nebula. Now, at the moment, this is almost in the right position. It's swinging around a bit. It's a bit higher as it's curving around towards the meridian tonight, 11:30. The ONC has a wide range of galactic objects and phenomena that make it aptly known as, quote, by Robert Burnham, remember Burnham's Celestial Handbook? Beautiful, our Bible. Well, it was back in the 60s and still you can still buy it, I think, can't you? Yeah. An astronomical treasure house, a great celestial laboratory for the study of the growth and evolution of stars. Anyway, and that's just repeating what I said earlier about the number of clusters and things. And this is a lovely map. It's in Wikipedia. You can blow it up to quite a size. You can't read those. They're much too small here, of course. There's another map of the local group, so I'll leave that and move on. So here are some of the deep sky objects inside the Large Magellanic Cloud. NGC 898 is a beautiful globular cluster, and it resides right in the middle, in the central part of the bar. This one on the right here, 1850. Look at this. This is amazing, this object. Now, they reckon this is, you can't find this object in the Milky Way because of its structure. So it's actually a young globular-like star cluster, a type of object unknown in the Milky Way, discovered by Dunlop. It is a visual magnitude of 9. This is extraordinary, really. It's very bright, and this is dense. It looks like it's forming a globular cluster, so they call it semi-globular. And then this really super dense cluster over here. NGC 1850 is surrounded by a filigree pattern of diffused gas, which makes it really unusual, which scientists believe were created by an explosion of massive stars. 1850, after the Tarantula Nebula, is the brightest star cluster in the Large Magellanic Cloud. So I'll be looking out for that one. Given its magnitude, it's probably worth looking at. The two components of the cluster, because it's a double, as you can see, the two components are both relatively young and consist of main globular cluster at the centre and the even younger, smaller one seen below to the right, composed of extremely hot blue stars. So these are very hot young stars, and faint red T-Tauri stars. The main cluster is about 50 million years old, the small one only 4 million years old. So, and this beautiful thing here, another globular cluster, courtesy of Hubble, NGC 1783. Isn't that spectacular? If only they were a bit closer, we'd be imaging these all the time. Less than 1.5 billion years old, magnitude 10.93. Okay. So, moving on, probably to the main event. I shall pause. Haven't brought any popcorn, Mitch? Okay. Looking at this now, the Tarantula Nebula is just, I'm sure some of you have looked at the Tarantula Nebula. If you image it with an ordinary CMOS camera, it'll look really green, as I've just covered, because you've got 2 green pixels for every red and blue one, and so it's going to look green through your camera. But its real colour is the one on the right or close to it, although I think that's probably a combination of infrared and other things. First observed, well not first observed, but observed by Louis de la Calle, whom you may remember I mentioned many times on the other constellation talks that we've had, who was in the Cape of Good Hope God, that guy did a lot between 1751 and 1753. A prodigious astronomer, prodigiously productive astronomer. He catalogued it as the second of the nebula of the first class. Nebulosities not accompanied by any star visible in the telescope of 2 feet. Now, I'm a bit puzzled by that line, in a telescope of 2 feet. Does he mean length? Does he mean diameter? It's a bit ambiguous. Anyway, it was described as a diffuse nebula 20 arc minutes across. So it's 1,000, in fact it's 1,000 light years across. It's a giant origin 2 region, a huge emission region, and the most powerful easily inside the Magellanic Cloud. In this complex of growing gas and very hot luminous stars, the gas is mainly composed of protons and electrons, which are kept apart by energetic photons emitted by the stars. 8th magnitude, it seems brighter than that to me, but it's only 8th magnitude, 160,000 light years away, of course. A diameter of 1,000 light years, and 40 by 25 arc minutes. There's a square degree. Now over here, here's the centre of it. Over here, this wispy area around here was the Supernova 1987A, which I have a photo of. Anyway, that's by the by. Down here is a brilliant star, VFTS 682. It's 95 degree light years northeast of R136. So, if you look here, you can see in the middle it's really bright, okay? Now, no matter how many photos we take of this, the middle is always overexposed because of this bright R136 star cluster. They're all very hot O-class stars and Wolfram stars, the hottest stars known. So, so in the middle here, you've got this enormous cluster, and here's another shot through different wavelengths. And in the middle of that are these massive stars, truly massive. And in fact, I'm going to show you one called R136A1, which is the brightest in the group, which we'll talk about in a minute. But this one here is 150 solar masses, 3.7 million times the luminosity of the sun. That when we say luminosity, that means all energy, all forms of light, if you like, all the way. So a prodigious amount of energy. It's at the very centre of the image, and of course you can't see it because it's lost in all that light. So I'll quickly move on. Another shot of the tarantula. You can see I'm obsessed with tarantula. This NGC 2070, which we always call out at Mount Pleasant. Can I look at, what's the tarantula number? Now they say that if you put it where the Orion Nebula is, it would cast shadows because of its sheer size. It has an absolute magnitude of minus 11.7. So what does that mean? So if you parked at 10 parsecs from us, which is 32 point something light years away, it would be extraordinarily bright. Extraordinary. That's almost the brightness of the full moon. The full moon's about 12 point something. So that's amazing. And imagine that's a gas cloud. The picture at the bottom right is my humble image from the 10th of October. You can see it's all green and blurry and grainy and as far from Hubble as you could get. But still, it was the first picture I ever took with my new camera. So I was worried about guiding. But yeah, anyway, let's move on. Here is R136 Close-Up. And you can see what an extraordinary bunch of stars. Known to include 72 class O stars. So you know those spectral classes, W, O, B, A, F, G, K, M? Right, well, W in the Wolfram, 50,000 degrees plus 50,000 Kelvin, extremely hot. O class are probably 35 or something thousand. So the extremely hot stars, the Wolfram ones, the W ones are the hottest of all. Within 5 parsecs of the centre of the cluster. So that's 20 arc seconds. So they're very close, dense cluster. R136 produces most of the energy that makes the Tarantula Nebula visible. It just energises it. The estimated mass of the cluster is 450,000 times the Sun. So almost 500 million suns. The central concentration of the cluster is 2 parsecs across. So that's about 6.4 or 5 light years. Although the whole cluster is much larger. R136 is thought to be 2 million years old. And the centre of the cluster, at the centre of it, is some of the most massive luminous stars known, including the one I told you about. Look at this. R136A1, a Wolfram Star, has the highest mass and luminosity of any star known, 315 times the mass of the Sun, and a staggering, we should be singing this, a staggering 8.7 million times the luminosity of the Sun. That's just mind-blowing, and that's better than Eta Carinae. I mean, Eta Carinae is I think 6 million, something like that. So that's extraordinary, so a radius of about 35 times the Sun, absolute magnitude minus 8.9, and less than a third of a million years old. Yes, Tom.
How is absolute magnitude defined?
As a set distance. So if you put all these objects at a set distance, then you can compare their real innate brightness.
What is the set distance?
The set distance is 10 parsecs, so 32 light years. I think that's right, isn't it, Mark?
Yeah,
somewhere. Yeah. All right. So anyway, just quickly, almost near the end, a pastiche of all the different, some of the objects in this are extraordinary, but you would never see these. These are hours of imaging through probably the world's biggest telescopes. But there are some wonderful things here. The Ghost Head Nebula, all these knots and wells. You can see this in images. You don't really know what they are until you look into this and you see these fantastic examples of stars causing this solar wind, if you like. This is through the Very Large Telescope, so you can see why they've got images of it. It's extremely faint. And this area is right near the tarantula. These are tarantulas. This area here is enlarged here for you. The Bean Nebula, not named after Mr. Bean, but it's at the very top. N11 is at the very top of here it is here, right at the very top of the Magellanic Cloud. Yes, so I just thought I'd show you a few objects from there before we move on. There are lots of these star-forming regions. All the red hydrogen out there, they're obviously emission nebulae, so that's where stars are being formed. Just quickly, we're near the very end now, penultimate slide. So this is a very famous object, Supernova 1987A, you might recall, many of you probably saw it. I was in my backyard taking photos with Andrew Kulkochuk, and that photo there is from my backyard, and there is the supernova, there's the Doradus or the Tarantula, and that's it there. And that was the second night. That was the 20th. I think it was the 23rd of February 1987, and that's the 24th. And we took these pictures, and the physics department finished my slide and duplicated it because they had a visual record. I did get it back. This has been a digital conversion of the slide, sorry. So that's from an original slide of 1986, Supernova 19. That's what it looks like. Well, it looked back in the 90s, the ring of gas colliding with an earlier ring. So it's actually quite an extraordinary phenomenon. And there's a picture of it as it was at its brightest near the Tarantula. So very close. The earliest supernova known images, apart from Kepler's supernova, its brightness peaked in May of that year, 1987, with an apparent magnitude of about 3. The progenitor star was a 12th magnitude blue supergiant, this is what exploded, called Sunderland 69202. Okay, so I thought I'd show that. It's very interesting, and that's Alma data over there. Yeah, it's very confusing when people see this in the media and they see these images like that so-called image of a black hole, which is really just a colour conversion of all sorts of radio wavelengths and an image. It's not really a real live image in the sense that we think of an image as a photograph. But, so it's misleading to see that. But anyway, that's quite extraordinary. It's a bit different. It's quite obviously.
Richard, there's a team from Cardiff that's announced this week that they think they've found the Neutron Star in the centre of all that.
Have they?
Yes, yeah.
That'd be very interesting.
I'm not sure how robust or how
No.
repeatable it is, but apparently